Hi and welcome to this video for the BTEC Applied Science Level 3, Unit 19. This is part of the second assignment, and it's for the merit and distinction bit where what you'll be given is a selection of spectra, and you need to work out the full molecule using them. So the difference between the merit and the distinction is kind of just how well you lay this out, analysing the possible pieces, whether or not there's any alternative structures, and so on. So the merit's more a bit of logic and whether or not you've got the correct structure. The distinction is the full analysis, any possible alternatives, and again, getting the correct structure with that. So I'm going to work through this one as an example. I don't really have much space. So when you're doing it on your assignment, you should be putting a bit more into it in terms of stating the peaks and what groups they correspond to and such, and maybe drawing them out a little bit more. Now at the top right, we've got the empirical formula. So again, just because I'm limited on space, I've taken the percentage elemental composition, worked it out, got C4H8O2. First thing I would do is I would want to know what the molecular formula is. So previous videos, you've seen me do this, where what we would do is we would look at the molecular ion. So this is at 88, we can see there. Do the molecular mass over the empirical mass. So 12 times 4 plus 8 plus 16 times 2, that's 88. So 88 over 88 is 1. The molecular is therefore C4H8O2 as well. So that's the first thing I'm going to do with a mass spec. We will come back to it in a bit. As you get a bit more skilled, you do start to recognise certain peaks, like the 29 here is typically a CH3, CH2 and such. But that takes a bit of practice to be able to memorise these numbers, such the CH3 in there being the 15. So anyway, C4H8O2 molecular. I would jump onto the infrared next. And what we're going to be looking for is just any key characteristic functional groups. Big sharp peak here, 15, 16, 17, just past 1700 there. So that's going to be our C double bond O. Because of the fact I've got two oxygens, I know one of them is going to be that. I want to have a think about, is the other oxygen going to be either an alcohol or form a carboxylic acid with this? So I would look here, see if there's any big broad peaks. There's not. Even saying what it's lacking is a good thing to include in your assignment. So say no OH group, because there's no big broad peak around either that 3230 to 3550 for alcohol or 2500 to 3000 for the carboxylic acid. So mentioning what's not present is also important. This here should be well aware that's just CH. Now the second oxygen, what it could be is maybe CO. But the annoying thing for that is that's down in the fingerprint region, 1000 to 1300. Could be any of these. Got no real idea down that area. But you can make a mention with a question mark, and we'll see later if it is present. Now, Proton NMR is the most powerful. To be honest, most of the molecules being fairly simple that you get, you can figure out with just this. But we'll try and use them all just for, again, good, thorough analysis of it all. So I'm going to come on to carbon-13 next. Now, this peak up here is of interest to me. It's in the 160 to 185 range. So I know that that is the carbonyl in either an ester or acid. Now, the infrared has told me there's no OH group, So I can rule out the acid. Again, make mentions of this, link them. So I know I've got an ester. So the other thing I would look for is just to confirm that I should have a peak between 50 and 90 because the ester functional group is this. And I can see I do here 50 to 90. So there's the C single bond O peak. As for these two, both down in that 5 to 40 region pretty much, or 20 to 50, we could say for this one. So we're a little bit unsure whether or not this is either the carbon next to the C double bond O here, or if it's just a C bonded to an R group essentially. So we'll come back to these two in a moment. Now the Proton NMR, we can see we've got 3 environments, whereas up here in the carbon-13 we had 4 environments. The reason for that, this carbon there, as we can see, is not going to have any hydrogens attached to it. So there is going to be a carbon off this left-hand side. Now I've got a singlet, a quartet and a triplet. Triplet quartets are nice to see. They are fairly indicative of CH3, CH2 group. So this being the triplet and CH2 being the quartet. And as we can see with the integration values, the 2 and the 3 in there. Now the 3 here means we're going to have a CH3 as well. It's a singlet, so it's not going to be adjacent to any carbons with hydrogens on them. So I'm going to put that over this side. Now what CH3s are good for is they're like jigsaw end pieces. We know we've kind of got this middle bit to fill in. So we've got the 2 CH3s. We've stuck a CH2 on one of them. Doesn't really matter which yet. Or if we check what we've used, 1, 2, 3 carbons. We've used 3, 4, 5, 6, 7, 8 hydrogens. So we've just got this COO group, the ester, to put in the middle. Now we've got a choice though for which way around to put it. We could either have it in like this, or like this. And it will give us different spectra. So this one here is methyl propanoate, the red one, whereas the black one would be ethyl ethanoate. So there are 2 different esters. Now, for how to figure it out then. What we are going to look at is the chemical shift of these peaks. So if we look at the singlet first, the singlet we know is this CH3 because whichever one of these it's next to would not split it. There's no hydrogens there. So the chemical shift, it's around 3.6-ish. If we look at our data table, we can see, is it written? You will have that listed as the 3.7 to 4.1 chemical shift range. This singlet, the CH3, matches that shift range. So it means it's directly connected to the oxygen rather than the C double bond O. If it was next to that, i.e. like that, we would expect this singlet to be in the 2.1 to 2.6 range, which it's not. So therefore, this way is correct. This was a possible alternative, which we've considered. Again, distinction, consider possible alternatives. But we are discounting it because the singlet is not in the correct chemical shift position. You could have done the same with the quartet down here. You'll see the quartet does match the 2.1 to 2.6 range, i.e. the CH2 being next to that, whereas we would expect the quartet to be at the 3.7 to 4.1 range if it was like this. But again, it's not, so I'm just going to quickly go back to the structure we had. So my methyl propanoate is the correct structure. Just to double check that, filling everything in, what we can see here. So this is CH3 there, it's the triplet. And since it's an RCH3, it fits between that 0.7 to 1.2. Quartet is there. It's in the 2.1 to 2.6 range because it's next to the C double bond O. And the singlet, we've just said that 3.7 to 4.1. Looking up at the carbon-13, just to confirm it, if this structure is correct, we've done this one, the C double bond O. We've got the CH3 here, which is connected directly to the oxygen. And then down in this region, this would be the CH2. Next to the C double bond O, so that's in the 20 to 50 region. Whereas the CH3 on the end, that's connected to an R, that's in the 5 to 40. It's well away from any of the electronegative atoms, so it's fairly upfield. Now with the mass spec, coming back to that, in terms of the simple fragmentations, you can see if I break the carbon-carbon bond there, I can get the CH3 coming off. If I snapped off in there, there is my peak at 29, the ethyl group essentially. If I snap CH3 from the other end, taking away 15, peak at 73, so not really stable, losing that. Whereas if I made a snap between the C double bond O and O in there, that would be losing 15, 31, so 88 take away 31 gives me 57. Oh, that's a very stable peak in there, so we would definitely be seeing that fragmentation occurring quite a lot. With that. Now, you don't need to be able to label every fragment on a mass spec. There's all sorts of rearrangements and such take place that are beyond this level, but the common peaks you should be able to identify. And that's it. Fairly detailed walkthrough for that, but that's kind of what you're after for merit/distinction, depending upon how logically you've talked through the possible structure that you've got. Thank you.